All right, good morning, everybody, to this lovely Tuesday. I hope everyone had a good Thanksgiving. Just before we start, can I just get confirmation in the chat that you can both see and hear me as usual? And then we'll get going. All right. So you had the task of starting to think about Babylonian arithmetic, where we're going to do the same thing as we did with the Roman numbers by looking at the methods we know for addition, subtraction, multiplication, but staying within the number system. We're just now doing it for the Babylonian numbers. So let us maybe just do one addition and one subtraction question, and just to see if there are any questions on those two before we go to multiplication. So let's do addition, and I'm just going to make up my own because I can't remember if in the video all the exercises were done or not, so we'll just make our own one, right? Okay, so let's do like 3 digits here, or not 3 digits, 3 places. Let's say here maybe, why is my pen so, I have to get into the Babylonian writing again. Let's maybe make 20, let's make it nice and big, like that. And let's make the last one maybe 54. And we're adding. Let's just add some numbers here. Let's make this also a 50. Let's go with 7. And let's say this is 25. There we go. That should be totally fine. Okay. So now we are looking at the same method as always. We just have to stay within the Babylonian number system. Now, when I look at one column at a time, I'm still saying the numbers in my language, of course. That's a little bit too much to ask to change how we say the numbers. So what do we have here? We have 54. Now I can't go and write 54. I just need to say it in my head. 54, 54, 54. Plus 25. 54 plus 25 is... This is where you say stuff. You came all this way. You've already done addition. This should be easy enough, sort of. 54 plus 25. 79. But now I have the problem. So let me put 79 in the chat. Let me see it. So we have something to see, right? I could put it on my calculator, but I can't put it on the page. So I can sort of cheat a little bit. 54 plus, what did we say, 25? So at least now I can see it. That helps a lot. But I'm counting in groups of 60, and that 79 is too big. It is too big. So I need to split it up into a group of 60. So one group of 60 will be carried over, and then I'll have 19 left. No, not easy, not easy. As long as it becomes easier with time, that's what we're aiming for. I spoke too soon when I said it's easy. I'm sorry. I apologize. I'm so sorry. It's not easy at all. As long as it gets easier with every example. Okay. So that was 60. One group of 60 carries over. And 19 then obviously will be left. Now we move on. Some people like this one more than the Roman numbers. I don't know. It's really personal preference. Now I move on to the next column, which is the 60s column. But I don't need, the nice thing about our method is I don't need to say one group of 60 plus 29 groups of 60 plus 57 groups of 60. I can just drop the groups of 60 attached to every single thing I'm going to say and say 1 plus 29 plus 57. And that's important to realize that I'm not actually working with 1. I'm working with groups of 60. But we just relax that because the words groups of 60 is attached to every single thing we're going to say here. Therefore, we don't need to say it. It's always going to be there. So I have 1 plus 29, that's 30. Oh, that's nice. That makes it easier. 30 plus 57, that's 87. Let me see 87. I just want to see it, right? It helps me. There, I just see it. If you're struggling to keep track of everything in your head, knowing you can't write these decimal numbers down, you can at least maybe use your calculator or something. You do have some options. 87, again, it's too big, but it's only going to be one group of 60 that carries over, and then, of course, leaving 27. 7 little ones like that. And then the last column should be, well, let me just change my arrow here. We're in the last column. We're just adding the 1 there. That should be quite straightforward. If I can draw 10 symbols that are decent, and I'm done. How do we feel about addition? Now, it's very important that you don't rush to subtraction, to multiplication, when your addition isn't feeling okay. It's just going to get worse. You need to build this up correctly, right? So I'm doing one addition, just double check if there are any questions at this stage. Tomorrow we have a catch-up session, so you do have time. We are taking our time with this because I understand, no, actually it is not easy. I agree. But it's more just getting used to the differences, right? There are a lot of similarities. Our method is the same. A lot of things are similar to what we're used to. But when you look at it, it really doesn't look like it. No questions at all? Oh, see, then maybe it is easy. Maybe my original statement was correct because there are no questions. All right, then. That's the only conclusion that I can make. But if you're so lost you don't even know what to ask yet, maybe get ready for tomorrow. Use the open question and answer session. I can only answer if you give me questions. All right, let's do a subtraction. Whoops, I'm in eraser mode. That would not make sense. Subtraction. Okay, so I'm just going to make one up here. And I want to do exactly what I did with the Roman numbers, where let's see how bad we can make this. And then anything I see in the future is not going to be so bad. So let's do it. Let's take 1 and then a space, and let's take maybe, I don't want to take too many. Let's maybe take something like that. Or actually, let's do the next one is nothing. There we go. And I'm subtracting. Let's subtract. We don't even have to subtract a lot. Let's subtract 30. And then let's maybe subtract, I want to subtract more here. 43. And then I'm not subtracting anything else. Okay, there we go. Knowing that my method does not change, I am still starting with the ones column. Now I see I have nothing and I need to subtract 30, excuse me. So clearly that can't be done. Let's use some color to keep track of what we're doing here. I'm going to go borrow this guy, 1. He comes over and splits. That's really one group of 60. Now imagine that's a little bag holding 60 things. When I borrow it and it comes over, the bag splits open and I see all the stuff inside. But of course, I don't have an easy symbol for 60. So at this stage, I think it helps me to just list everything that is in the bag. It doesn't matter how. It's not a Babylonian number, it's just individual tens being contributed to the ones column. I think that is the easiest middle ground. Then I'm ready for the subtraction. Actually, it's super easy subtraction. Because the whole point of the method that we do is to isolate the whole problem by looking into little pieces, isolate little pieces, column by column, and make that subtraction only what the thing you do. That subtraction is easier. 60 minus 30 is 30. My tens are not looking great today. I apologize. That's really not good. They can at least be a little pointier. Ooh, now that's way too pointy. I went too far. Anyway, I'm going to stick with it. Then I am moving to the next column. Now remember, this guy's not here anymore, this pink one I borrowed. He's out. He's gone. He doesn't exist for that column anymore. So I only have 11, and I need to take away a whole bunch. That's not going to happen. I'm going to borrow this one guy. He's going to disappear, and he's going to come over and become 60. Now I know actually what's happening here is this is one group of 60 squared. That is the same as 60 groups of 60. But because I just focus on a window, I can always look at my column that I'm in as if it was the ones column. When I look at the pink window, I was over here with the one. I was actually in the ones column, and in the column next to me is groups of 60. If I'm in the second column relative to that column, the next column is groups of 60. Because I'm in the 60s column, it's actually 60 groups of 60, and then another group of 60. But I can look at it sort of with blinders on, only relative to the column I'm in, and then repeat the same thinking, which is why the method is so efficient. Because I just do the same small calculations over and over and over. Even though I'm working with much larger numbers, I don't have to think about it at that specific stage because of the place value property. So now I've borrowed my 6 tens relative to this column. And so I have to be in blue. So that is what I have available to me, and I have 71. 71, take away 43. Well, 71 take away 40 is 31. Take away another 3 is 28. And then I just represent 28. And then in the next column, there's nothing left because the one guy that was there, I borrowed. He's not there anymore, so I'm done. It can be easy with practice, with time, and with paying close attention to what the method is doing, what it's allowing me to do, how it's making things easier, how it's allowing me to focus on pieces, column by column, or maybe a column and the next column. Regardless, I could be 5 columns in. The way I'm saying what I'm doing is going to be exactly the same because it's all relative to that column. And it could be very confusing for little Timmy. If you say, now in decimal, of course, you're in the tens column, though you talk about it as if they're ones, 7 minus 1 or whatever it could be. And it's very confusing if a student really thinks about it. But I'm not in the ones column. How can I say things as if they're ones when I'm not in the ones column? And you need to then have a very good understanding of how this works so that you have the answer. And you're not one of those teachers that just say, no, that's just the method. Just do the method. Don't think about it. So many people do that because they don't understand it. Well, I'm sorry, but if you don't really understand what you're teaching, then you shouldn't be teaching. And that's just the fact. There are too many people that are in front of a classroom that don't understand what they're talking about. And then they just, that lack of explanation creates a small little seed of anxiety. If my teacher can't explain it to me, then how am I gonna? That means she maybe doesn't understand it. And then how am I supposed to understand it? This is impossible. And that little bit of anxiety and uncertainty grows into something much bigger. Any questions on subtraction? See, again, no questions. It must be because it's super easy. Or it could be because my audio isn't working anymore. Can we get confirmation that you can still see and hear me? Because now I'm starting to get paranoid.
Yes.
Okay, so then it must be, my only conclusion is that it's just that easy. Great. That's good news. Because quiz number 2 is going to be very predictable in its questions. These are the only questions we've done so far. It's just going to be full of conversion and arithmetic. Or you've just all been waiting for the wonderful world of multiplication. Now, as we've seen before, multiplication isn't really that big of a deal, especially because we're going to take the long, detailed version. But I do want to see some questions, the exercises. I will just copy them over and I'll do you a favor and line them up for you as well. Because our second number isn't going to be super hard, it's usually pretty easy to line it up for multiplication. We have 10 and 3 ones, and then a space, and then 40. 9, really? Why? Why 9? Why? Because I need to practice, I guess. And then a 12. I can use my time symbol. That's nice, because nothing else looks like that. And we're going to multiply by 5. So we're going to keep the second number nice and simple. So that for the most part, not that you have to, but you can do some mental arithmetic practice at the same time. That's always a good thing. Okay, let me just close my PDF here so I can see the chat. Okay, so now method doesn't change. I am looking at the first column. I'm doing it backwards just because the 5 stays the same always. 5 times 12. Now 5 times 12 I know is 60, which means I have one group of 60 and nothing. How does that feel? So it is the same what I'm doing when I did it in the Roman numbers. I just did the multiplication and then wrote the representation of the answer that I get. Here I'm doing the same thing. I am doing the multiplication and I write the representation of the number that I get. It just happens that the number that I get is 60. And I'm counting in 60s, which is why I represent it as one group of 60, and then of course nothing is left. It is up to you to ask. I cannot sense magically your questions. Then I go to the next column and I say 5 times whatever this is. What on earth is this? This is 49. 5 times 49. Now, just to show, you have the option. You have a calculator. Use your calculator if you don't like it. I like to, even if it takes longer, in this situation or when you're practicing, try and do a mental calculation. 5 times 49. Can I do it? And then maybe verify it with your calculator. You should get the same answer, and it's good practice. You have to force yourself to stay sharp. But let's do it anyway. 49. And of course, everyone got 245, right? Why wouldn't you? But you can get that confirmation, use the calculator, and then you can see. I can't write 245 here, right? If I write 245 anywhere, then I lose marks. And this question isn't going to be worth that many marks. So I could very easily lose all my marks, even though I know how to do it. So do not do that. I see people every semester, they still do it. And then they can easily get a 0, even though they might know how to do this. Do not show any other numbers here. So 245. So now I need to break that up into groups of 60. Now remember, I'm in the groups of 60 column. So really what I'm doing is 5 times 49 groups of 60 is 245 groups of 60. But there's the words groups of 60 is attached to everything. Therefore, I don't have to say it every single time. So I can just focus on 245 as if it's the number 245. But actually it isn't. That's the beauty of this method. So 245 needs to be split up into groups of 60. Oh, actually I can pad it here, right? I'm actually going to start my number in the same column. Yes, that helps as well. So it'll be how many groups of 60 in 245? I can't do everything. You have to do something. I know what you're thinking.
4.
4. You are very quiet. I'll try and turn your volume up. 4 groups of 60. So I will write the 4. Then I obviously have 5 left, so I will write the 5. Moving on to my next column. I know I'm going to start in that column, so I pad it with quote-unquote zeros. And now I have 5 times 13. 5 times 13, maybe you want to see it. Maybe you are okay not seeing it. You have options. Then you can see the 65 is going to be one group of 60 and another 5 left over. Now I need some space because I'm going to add. I add the ones column, it is nothing. Then I have 1 and 5 will be 6. Then I go to the next column, and that is 4 plus 4 plus 5. That's 9. Let me draw my 9 ones. And another one here. And there we go. Any thoughts on that? No thoughts at all. I'm getting suspicious. Something is going on. Is it the polar bear? You don't want to look. You don't want to talk to him. He's a friendly guy. All right. Well, I can't force you to ask questions. You don't want to. We'll do the next one. Let me open my question here. Whoopsie. It's not number 2, it's number B. That's a B. Okay, we have 25. Space, I'm so far to the left now. Whoops, that can't be good. That's a bad idea. Because I might get another column. 20, let's put the 25 over here. And then we have an 11. And then we have a 5. And then we're multiplying. And we're multiplying by 7. Ooh, nice. Good practice. All right, let's do it. First one, 7 times 5. That's 35. That can totally fit in my ones place. No problems at all. Then I'm going to go to the next column, pad it with my empty symbol, so everything is nice in line here. I have 7 times 11. That's 77. That's too much. So that's going to be one group of 60 and 17 left over. Moving up a little bit. Now I'm going to multiply with my third place. So I'm padding with empty symbols just to help me keep everything in line, though technically I should. Yeah. Because we have this symbol. We didn't have it in the Roman numbers. So our space was emptiness in those areas, I'll say. But here we have specific places, and every place needs to have a symbol. Empty space is not a valid symbol. 7 times, 25. Is it 25? Yes, 7 times 25. Well, 7 times 20 is 140 times plus another 7 times 5, which is 35. So 175. No reaction. Okay. 175. How many groups of 60 can go into 175? Oof, almost 3. So close to 3, but sadly only 2. That uses 120, so I still have 55 left. Good practice to draw stuff, though my 10s are not looking great today. Still recognizable. And then I add all these up. So in the ones column, I have 35 and nothing else. So that is just brought down. There we go. Then, in the next column, I also just bring it down. Well, that is very convenient. Not much to do today. And the next column, I don't even have much to do. I just merge it. So the adding is super easy. Seriously, my tens are not looking good. Come on. Ooh, nice and curly. I like it. That's better. Get some style in there. Be 6, right? And then 2 comes down. So you'll see here in the addition, very rarely do I have anything that carries over and makes the addition complicated. Whoopsie. And there we have another one. Very predictable. You have to be able to do these. We don't know which one will be asked down the line, so I have to be ready for all of them. How does that one look? Of course, it looks great. Your silence says everything. Next one is a last one. I don't know if this one's more difficult. They're just more questions that we need to practice. Maybe it shows something. Maybe it doesn't. I don't know. We have a 10. I'm going to make my 10 a little bit more curly. It looks nice. 5. Space. 20. Yeah, those are 10s are nice. And then space and another 20. And we're going to multiply by 10. We can multiply by, I'm going to stick to single place numbers for the second number, but that can go up to 59. So those are all fair game. Now let's go. First column, 10 times 20 is 200. That's too big for that column. 200 will be 3 groups of 60, making 180, and another 20 left over. Next column, so I pad it with my empty place symbol. Let's move up a little bit. Then I say the exact same thing, but relative to that column, 10 times 20 is 200. That's again going to be 3 groups of 60 relative to that column, plus a very curly 20. Third column, so I'm padding it with my empty symbol, so everything is in line, plus I have to do it. 10, actually a very nice number to work with. 10 times, what do I have here? 15. Nice. 150. Super easy. Don't need a calculator. 150 will be 2 groups of 60 using 120, 30 left over. And I am pretty much done. Now the addition. Not much to add here. I'm just pretty much bringing everything down. Ooh, that is not a good 10. Come on, come on. It's not much better. I have my 20 that comes down. I have another 23 for the next place. I have 33 and a 2. And that is it. Multiplication. Same method, different appearance, but that doesn't change. Oops. That is it. Multiplication. Same method, different appearance, but that doesn't change what I am doing with these numbers. And what we're ultimately trying to develop and improve on is our understanding of what these arithmetic methods are saying, when they're saying it, why they're saying it, and so on. So we are practicing this in the Roman numbers, and in the Babylonian numbers, and then we'll start heading towards more modern times. But that is all we have to do for Babylonian numbers. We have to be able to convert back and forth, and we have to be able to do addition, subtraction, and multiplication in that system. Exactly the same kinds of questions as we have for the Roman numbers. And then, because of the long weekend, I have a catch-up session planned for tomorrow. There's no need to rush. You decide if you need to use it or not, and then we'll slowly move on with the chapters. That is all I have. Are there any questions or comments you'd like to bring to everyone's attention?
I do have a question.
Yeah.
More of a clarification, but with the Roman numerals, we counted each section by tens, right? Or adding zeros. But for the Babylonian numbers, these are by 60s, right?
Yes. Now, the Roman numbers don't actually have places because for the tens numbers and the hundreds and so on, they're brand new symbols. So they don't have the need to split it up into places, because if you see a C, you know it's in the hundreds potentially. But with the Babylonian numbers, they are recycling the same symbols and therefore need separate places for us to be able to understand the number. But underneath the Roman number system, there are, or we can look at it as places of ones, tens, hundreds, and so on. But technically, it's not a place value system.
Okay, thank you.
Any other thoughts, questions, comments, complaints, criticisms, compliments? No. All right. Then we will maybe see each other tomorrow. Until then.
Please remember to click the like button if you enjoyed the video, and to subscribe if you want to be notified of more videos. Thank you.